In this video, I want to quickly go over solving exponential equations without using logs. So as we've gone over in class, the goal is to get the equation to look like this so that I can use this fact to solve for my variable. So if I have the same base on either side of the equation with two different exponents, I just set the exponents equal. This makes it easy, but getting there to this form might not be so easy sometimes. To help us get there, we want to use some properties of exponents that we should have already learned, but we want to review. So the first being, if I have something raised to an exponent x, and that is raised to another exponent y, then my answer is b to the x times y. The reason for this is if I have 2 squared to the third power, that's really 2 squared times 2 squared times 2 squared. And so you can see I have 6 2's, and so that is 2 to the 6, which is 3 times 2. Another property we want to use is the fact that if I have b raised to some exponent x, and that's times b raised to some other exponent y, then when I multiply these, the result is just b raised to the x plus y power. To prove this, let's take 2 squared times 2 cubed. If I write these out, 2 squared is 2 times 2. If I multiply that times 2 cubed, that's 2 times 2 times 2. The result is 2 to the 5th, and 5 is 3 plus 2, so this fact, x plus y in the exponent, is proved. The next property we want to know, or want to use, is if I have b to the x divided by b to the y. Now the result of this is b to the x minus y, and let's look at an example to help us with this. Let's say I have 2 to the 4th divided by 2 squared. 2 to the 4th is 2 times 2 times 2. 2 squared is 2 times 2. And I know that if I have the same number on the top and the bottom, I can cancel them out. And the result is 2 squared. And we all know that 4 minus 2 is equal to 2. Lastly, we want to use the fact that if I have 1 over b to the x, this can also be written as b to the negative x. Now why is this? Let's say I have 1 over 2 squared. If I multiply by 2 squared, these cancel and I just get 1. Likewise, if I have 2 squared times 2 to the negative 2, from a property that we just learned, the result is 2 to the 2 plus negative 2, and that's 2 to the 0, which is 1. So now that we've seen the properties, let's do some examples and use them. So the first one I do is 8 raised to the 4x plus 2 is equal to 64. Now let's go through the ways that I can write these. 8, the way that I can express that in exponents is 2 to the 3rd. So if I substitute in that for 8, then it's 2 to the 3rd raised to the 4x plus 2. Now the goal is to get the same base, so I need to write 64 as 2 raised to something, and that just so happens to be 2 raised to the 6th power. So this side stays the same. If I have these two raised, or if I have 2 to the 3rd raised to the 4x plus 2, the first property we went over stated that I just multiply the exponents. And so 3 times 4x is 12x, plus 3 times 2 is 6. Now I have the same base, so what do? I set the exponents equal to each other, and when I solve for x, I get 12x is equal to 0, so then x is equal to 0. And I'm done. Let's do another one that's a little more complicated. Let's say I have 1/5 raised to the x minus 5. That's equal to 25 raised to the 3x plus 2. Now I know that 25 is the same as 5 squared. So if I substitute that in, I get 5 squared raised to the 3x plus 2 on the right side. On the left side, I don't need this fraction, so by the fourth property that we looked at, this 1/5 is the same thing as 5 to the negative 1. So I have 5 to the negative 1 raised to the x minus 5. Now I've got 5 as each of my base, so let's use another property. A power raised to a power, I multiply them. So this is really 5 to the negative x plus 5 equals 5 to the 6x plus 4. Now my bases are the same, so I set the exponents equal and ignore the base. So negative x plus 5 is equal to 6x plus 4. So I can add this x over, subtract this 4. So the 4's cancels, the x's cancel, and I get 1 is equal to 7x. So then I have to divide by 7. And x is equal to 1/7. So that's how we solve these equations without using logs. And I hope this video helps and can serve you to help learn the material well.